Dear students, I am Santan, working as a physics faculty in Target English Medium School. Today, in this part 2 video, I would like to teach or explain about the remaining eye defects in vision. In our previous video, we clearly discussing what is the hypermetropia. Hypermetropia is also one of the eye defect. So now in this part video, we continue for that one. That is the another defects of eye is nothing but what is presbyopia and how we can correct it that one, and what is astigmatism and how we can correct it that one. So that's why our third one is presbyopia. So a person cannot able to see the nearby as well as far objects simultaneously or at a time. That type of defect we are called presbyopia. Once again listen very carefully. So in our previous videos, under the defects in vision, how many types of defects of vision basically occurs? 4: myopia, hypermetropia, presbyopia and astigmatism. So what is hypermetropia? A person can able to see nearby objects clearly but not see the far objects clearly. That type of defect we are called myopia. So myopia we are also called as near or short-sightedness. It is corrected by using the suitable concave lens. And what is the main reason arises this one? So the curvature of cornea is increases. It is more than the length of the eyeball. That's why it is arises. Hypermetropia, second one. A person can able to see the far objects clearly but not the nearby objects. That type of defect we are called hypermetropia. So the curvature of cornea is decreases than the length of the eyeball. That's why the rays are meet behind the retina after the refraction by our lenses. That's why to correct the hypermetropia we are using the which lenses? Convex lens. So that's why in myopia we can see the near, in hypermetropia we can see the far. But in presbyopia is nothing but a person is suffered with a presbyopia eye defect. At that time means the person cannot able to see the far objects and nearby objects at a time. Means he was not able to see the near objects and also far objects simultaneously. So generally it is occurs along with aging. It is occurs along with aging. Means our age is increases when we become to older. At that time most of the persons are not able to see the nearby and far objects simultaneously or at a time. But what is the main reason for the presbyopia means? So our eye lenses will be losses the power of accommodation. Is nothing but adjusting the focal length in nature. That's why it is arises due to the loss of power of accommodation, or is nothing but loss is the adjusting of focal length by our lens with help of the ciliary muscles. But how we can correct the presbyopia? That's why we know that to correct the myopia, for seeing the far objects, we are using which lens? Concave. In case of hypermetropia, for seeing the nearby objects, we are using the convex lens. That's why presbyopia means you was not able to see near and far. That's why you must be use both convex and concave lens. That's why it is corrected. Which one? Presbyopia. It is corrected by using bifocal lens. Bifocal lens is nothing but both concave and convex. Both concave and convex. In spectacles. In spectacles, okay, in spectacles, upper portion is concave lens. Lower portion is convex lens. So it is okay, one lens in spectacles. That's why in this total, okay, we consider the half of the part. This is the upper portion, this is the lower portion in the specs. In the specs, lenses are there or not? In this one only we can say that. In this one, half of the part is means upper portion, we can say lower portion. So that's why this upper portion, which lenses are used? Concave lens. This lower portion, which lenses are used? Convex lens. That's why what will happen with help of the concave lens, we can see the far objects. With help of the convex lens, we can see the near objects. That's why by providing these two lenses at a time in the spectacles, that's why a person is suffered with presbyopia was able to see the far and near objects at a time. Next one is astigmatism. This concept is not in our textbook of 10th standard level in state syllabus. Just listen. A person cannot able to see the object clearly. A person cannot able to see the objects clearly by forming in two orthogonal directions. These two orthogonal directions are different. It's nothing but these two are not in the same. They are formed at the different positions. So here you are observing that the rays are coming from the object. If a person is suffered with the astigmatism, at that time what will be happen means, okay, so the focal length of our lenses will be different. Due to that reason, okay, so the two images will be formed in which one orthogonal directions is nothing but, so one image will be formed at one position, one image will be formed at the another position. That's why we know that, okay, if the rays are coming from the object, for example 10 rays are coming from the object, the 10 rays are, okay, after the refraction exactly they meet on the retina, then what will be happening? So the, okay, the photoreceptors present on the retina is grab the information coming from all the rays of the object, and what is its intensity, what is its nature, and color, everything it will be find out there. But the rays are coming from the 10, okay, just you can say 10 rays are coming from the object, 5 rays are meet at one point and form the image, remaining 5 rays are meet at another point, form the image. That's why what will be happen, our eye or the photoreceptor present on the retina is not grab the exact information, actually not like this one will be here, one will be here like this. Sorry, not like that one. Okay. Like that. So some rays are meet at one point, some rays are meet at another point. Okay. So I will draw a simple diagram about this one. So that what will be happen? Okay. So like this one. So that's why what will be happen? Okay, 2 rays are meet at one point, 2 rays are meet at another point. Okay, so means some of the rays are meet at one point, some of the rays are meet at another point. That's why these two are in two orthogonal directions are there. Then what will be happen here? Okay, so total, okay, 5, 10 rays we can say that total 100% of intensity. In the 100% of intensity of the light, 50% intensity of the light, by that one image will be formed at one side, remaining 50% intensity of the light, it will be formed at another side. Due to that one, what will be happen? The photoreceptors present in the retina is not grab the exact information of the coming, okay, of the object, because of, okay, the intensity of the light will be, okay, changes, because of in 100% some part will be go to one side, some part will be go to one side and form that one. So due to that okay way, but actually these two are not at long distance, these two are very near. Due to that's why what will be happen, you are not able to see the object very clearly. Listen very carefully. A person cannot able to see the object clearly by forming, okay, clearly by forming in two orthogonal direction. That's why the type of defect we are called astigmatism. But how we can correct the astigmatism means, okay, by using cylindrical lens. So astigmatism eye defect we are corrected by using the cylindrical lens. Listen very carefully. Myopia is corrected by concave lens. Hypermetropia is corrected by convex lens. Presbyopia is corrected by both concave and convex lens. But astigmatism is corrected by using the suitable cross section of the cylindrical lens. These are a brief idea about the which one means okay, defects in vision. And one more simple topic is also there, that is also we discussed in this time. That is Power of lens. The reciprocal of focal length of lens is called power of lens. Power of lens is measured its ability to produce, its ability or the degree of divergency or convergency. The power of lens is measured its ability to produce convergency or divergency of lens. Listen very carefully. So nothing but the power of lens is mainly gives the what type of information, means what is the degree of the convergency of the lens, what is the degree of the convergency of the divergency of the lens. That's why. So what is the degree of convergency and divergency of the lens is measured simply by using the which one? Power of lens. So what is the main definition? The reciprocal of focal length of lens is called power of lens. Formula for power of lens. Formula for power of lens. According to the statement or definition, the reciprocal of focal length. That's why P is equals to 1 upon F in meters. And 100 upon F in centimeters. But mostly when they are asking the any numerical about the power of lens, at that time mostly we are using the which formula? Second formula only. Why? Because of the focal length of the lens is always we measure in centimeters, not in the meters. Due to that reason, meter is very high quantity. That's why. So instead of the first one, we are using the which one? Second one. P is equals to, P is nothing but power of lens. So the reciprocal of focal length is called power of lens. 1 upon F is in the meters. This is the formula. 100 by F, it is in centimeters. Because of 1 meter is equals to how many centimeters? 100. Unit is diopter. D. 1 diopter is equals to 1 meter inverse. Because of, we know that, P is equals to 1 by F, means focal length. Length is measured in meters in SI system. This meter bring to the numerator side. P is equals to m power minus 1. P means power of lens. What is, meter is the SI unit. That's why, what is the unit of the power of lens? Diopter. That's why D equals to meter power minus 1. So the reciprocal of focal length is called power of lens. What is the use of the power of lens? With help of the power of lens concept, you can easily find out what is the degree of convergency or divergency of the lens. Or what is the ability to produce convergency or divergency of lens. So P equals to 1 upon F in meters. P equals 100 upon F in centimeters. Its unit is diopter. It is denoted by the capital D. 1 D equals to 1 meter power minus 1. The power of convex lens is positive. The power of concave lens is negative because F is equals to positive here F is equals to negative. Already we know very clearly the focal length of the convex lens is always positive. The focal length of the concave lens is negative. So that the power of the convex lens is always positive. The power of concave lens is always negative based on their focal length. Now we are discussing two numericals based on the power of lens concept. So first one, a doctor advises to use 2D power of lens. What is the focal length of that lens? Listen very carefully. A doctor is advises to wear the 2D power of lens. So what is its focal length of the lens? So power of the lens is, what is that one? 2D. No value is nothing but plus 2D. That is one. You can find which value? Focal length of the lens. We know the formula. What is that one? Power of lens is equals to 100 upon F in centimeter. Okay. Now from this one, F is equals to 100 upon 2. D is the unit. Okay. That's why F equals 100 upon 2. Sorry, F is equals to 100 upon P. From this one, we can write like this one or not? Okay. P equals 100 upon F, then F equals 100 upon P. So that's why F is equals to 100 upon, what is that one? What is the P value? 2. That's why 250. So F is equals to 15 centimeter. That's right. So what is the focal length of the length? 50 centimeter. Here, which value will become? Just says the 2D. That's why focal length of the lens is here. Which value? It is the negative value or positive value? Positive value. That's why you must be used which lenses? Okay, convex means the okay. What is the meaning of the? Listen very carefully. So a doctor advised to use the 2D power of lens. Find its focal length. So that's why focal length is 50 centimeter. Means plus 50. What is the meaning of that one? So the person, with help of this one, we can easily say that the person is suffered with which defect? Okay, hypermetropia. Because of the power of the lens is always positive for the which one? Convex lens. Convex lens is used for which correction of the eye defect? Hypermetropia. That's why. So the person, okay, is used with 50 centimeter focal length of the convex lens in the spectacles. Then he was corrected. Which one is hypermetropic eye? Next, okay, second one. The focal length of the lens is 25 centimeter. Find the power of lens. So this is the power. That's why direct formula P equals to 100 upon F. Then P equals to 100 upon 25. 25 4 joule. That's why P is equals to 4 units is D. So That's why 4D we are considering. Or for example here minus 25. What is the p value? Minus 40. Is nothing but you are using which lenses? Okay, concave lens. That's why the power of the lens is positive for convex lens. The power of the lens is negative for concave lens. Why? Because of the focal length of the convex lens is positive, focal length of the concave lens is negative. This is the way of the method to solve the numerical based on the power of lens when they are giving the power of lens to find the focal length, or they give focal length and find the power of the lens. Thank you.